Hello my dear students, hope all of you are well, and today I shall start the discussion of the periodic table of different characteristics, known as general characteristics in periods and groups. Previous day we already discussed about modern periodic table, how many groups are there, how many periods are there, that we have discussed. Okay, and which group is called alkali metal group, which group is called noble gas, which group is called halogens. Okay, already discussed. Now today we will start from the general characteristics, that means variation of different things, okay, in the period as well as in the group. First we will discuss the number of cells. Now, an element belongs to the period which is equal to the number of cells. Suppose if you think about hydrogen, okay, so hydrogen is a first period element, so definitely it has only one cell. Even helium also, okay, helium also first period element, it has only one cell. But if you go to the next period, like lithium, beryllium, boron, carbon, okay, so these elements have two cells because they are second period element. Next, if we go to the third period, that is sodium, magnesium, definitely these period elements have three cells, okay. And in a period, when we are moving from left to right, suppose if we take the example of sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. When you are going from left to right, the number of cells is same, okay. These are the third period elements, so three cells are there, and here when we are moving, okay, that means in the same cell, okay, that means what I am telling, that the cells remain same when we are moving from left to right in a period, okay. So number of cell is not changing, okay, and it is the if I tell that first cell is the K cell, second cell will be the L cell, third cell will be M cell. So the last electron of these elements, okay, that means valence electrons, okay, are entering into the N cells. But whenever we are considering a group, okay, when we are going down, definitely the number of cells are increasing, okay. Suppose before that sodium there was lithium, then potassium, then rubidium, then cesium, then francium. So when we are going down from top to bottom in a group, what is happening? So here number of cells is 2, here 3, here potassium 4, rubidium 5, okay, then this is 6, then 7. In this way, okay, the number of cells is increasing. Hope you can understand. Next we will discuss the atomic size. Now we always consider atom as sphere, okay, and the size of atom is measured by its radius, that is called atomic radius. Now atomic radius is the distance, okay, from the nucleus, okay, or the center of the nucleus to its the outermost cell. Suppose this is one spherical atom. Whatever cell I have drawn, this is the outermost cell and here is the nucleus. Inside there may be other cells also, okay. So if you take the center of this nucleus, and this outside, that means outermost shell, that distance is called the atomic radius. Hope you can understand. And in a period when we are moving from left to right, okay, the atomic size or radius decreases. Why? Because the cell remains same but nuclear charge continuously increasing. Okay, so definitely the outermost cell will feel more attraction towards the nucleus, and definitely the size will decrease. So again we can consider that from lithium to beryllium, boron, carbon, nitrogen, oxygen, fluorine, okay, from here to here the size of the atom or atomic radius decreases. Okay, but if we think in a period, in a group, this is in a period. Now if we think in a group, when we are going from top to bottom, okay, then definitely the atomic radius will increase as the number of cells are increasing. So lithium, then is sodium, potassium, rubidium, cesium, francium. So in lithium 2 cells, sodium 3 cells, potassium 4 cells. So number of cells increasing. So from the nucleus to the outermost cell, distance increasing, definitely the atomic size will increase. Hope you can understand what I am telling. Okay, so this minimum thing you have to read. Okay, whatever we are discussing. Next we will go to the another thing that is called valence cell electrons and valency. So we will discuss about mainly valency or valence cell electrons. Valence cell electrons and valency. All of you know that the outermost cell, the number of outermost cell are called valence cell electrons. Okay, and what will be the valency? Okay, valency is the combining capacity of one element with the other element, that is called the valency. Now you can take one example. Suppose in a period whenever we are discussing that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So from here to here what is happening? Lithium will be, number of valence electron will be what? 1, beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen 6, 7, then 8. This is the valence electrons. And next what will be the valency? Valency will be the 1 minus 1. In case of lithium it will be 1. Okay, in case of lithium the valence will be 1 as only one valence electron is there. So generally it will transfer one electron to any non-metal, okay, having the high electron affinity, okay, and it will show the valency 1, like lithium chloride, okay, like lithium fluoride, okay. So here valence will be 1. But in case of beryllium, in outermost cell it has 2 electrons, so it will show the valency 2. Then boron will show valency 3. We can give examples. Suppose this one is lithium chloride, this one is barium chloride, okay, boron dichloride, this will be covalent compound, okay. Then carbon valency will be 4, like CCl4, carbon tetrachloride. And in case of nitrogen it will be 8 minus 5 because 3, because to achieve the nearest double gas electronic configuration, okay, that means octet, to fill up its octet it can accept 3 electrons. So that is why it will combine with the 3 atoms, okay, so it will form NCl3. Hope you can understand. And in this case oxygen, okay, its valence will be 2, okay, and in case of fluorine it will be the 1. So oxygen valency 2 we can give, best example is water, and here also fluorine we can give hydrogen fluoride, okay, valency is 1, and in neon it will be 8 minus 8, its octet is filled up, so its valency will be 0. Hope you can understand. So what is happening when we are going from left to right in a period, okay, or moving in the same period, okay. So first up to 4, okay, valency is increasing, then again it started decreasing, okay. Finally in noble gases, okay, it becomes 0. Hope you can understand. And valence electron, if you consider, whenever you are going from left to right, okay, in a period, definitely the number of valence electron continuously increases up to 8 in the last one. Now we will discuss this thing that valence electron and valency, okay, in case of in a group, okay, whenever we are going, okay, in a group from top to bottom, the number of valence shell electrons remains same, okay. That means lithium, then will be sodium, then will be potassium, okay, then rubidium, okay, then cesium, then francium, all cases, okay, the number of valence shell electron is 1, so definitely they will show valency 1. So in a group, when we are going from top to bottom, number of valence electron remains same as well as valency also remains same. There will be no change. Hope you can understand. Next we will go to the metallic character. Metallic character and as well as non-metallic character, okay. Metallic character. Metallic and non-metallic will be just the reverse, okay. So metallic character of an element represents the tendency of an atom to lose the electrons, okay, very easily. And whenever in a period, whenever we are going from left to right, generally metallic character decreases and non-metallic character increases. Again we can take the same example: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So here lithium is metal, beryllium is also metal, lithium is alkali metal, beryllium alkaline earth metal, boron is metalloid, then carbon, nitrogen, oxygen, fluorine, these are non-metals, neons are non-metals. So metallic character, what is happening, decreases. And from here what is happening, non-metallic character increases. Here lithium has the least non-metallic property, okay, and non-metallic character, so this is the metallic character. Metallic character and non-metallic character increases. Non-metallic. Hope you can understand what I am telling. Okay. Now we will discuss in a group what is happening. So when you can take here lithium, then sodium, then potassium, rubidium, cesium, francium. So whenever you are going down, definitely the release of one electron will be very easy because distance increasing, so attraction of the valence electron towards the nucleus decreases. So it can release the electrons very easily whenever you are going down. Okay, so down the group, what will happen? Metallic character increases. Metallic character increases. Hope you can understand. And you can take another group from the non-metal, okay, like nitrogen, phosphorus, arsenic, antimony, bismuth. So here you see nitrogen, phosphorus, these are non-metal. Arsenic, antimony, these are metalloid, and bismuth is metal. So what is happening here? Also metallic character increases, and down the group non-metallic character decreases. Hope you can understand what I am telling. Next we will go to the nature of oxides. Okay, generally metals are forming the basic oxides. Okay, metal oxides are basic in nature. Okay, and the basic characters of oxides, okay, will increase whenever you are going down in a group. So here from lithium to sodium to potassium to rubidium, cesium, francium, if you consider their oxides, definitely the basic character increases. But whenever you are going left to right in a period, okay, or moving left to right in a period, in the same period, okay, what is happening? that metallic character decreases, non-metallic character increases. So this lithium oxide, beryllium oxide will be what type of? They will show that basic character, and the basic character decreases. Okay, carbon can form carbon monoxide, that is neutral, carbon dioxide, that will be the acidic, and nitrogen, oxygen, fluorine. Okay, so here fluorine oxide will be definitely acidic in nature. Okay, nitrogen oxide also acidic in nature. So basic character decreases, as well as acidic oxides, that means non-metal oxides are acidic, so acidic character increases. Hope you can understand. And in a group, we have already discussed that basic character of oxides increases from top to bottom. Okay, so in this way, you have to remember this thing. Okay, and actually sometimes there are some oxides, okay, that also called amphoteric oxide, like aluminium, boron. Okay, they can react both with acid as well as base. Generally, metals are forming the basic oxides. Okay, and metalloids are forming. Okay, sometimes aluminium is not metal, aluminium is also metal. They are forming that amphoteric oxides. Okay, and non-metals are forming that acidic oxides. Hope you can understand. Next, we will discuss another property, that is the properties of elements. Properties of elements. Here we mainly discuss the reactivity of different elements. Okay. Now, properties of elements depend upon their number of electrons in the outermost shell, that is the valency. And in a period when we are moving from left to right, the reactivity first decreases up to 14. Then it will increase, and then we will get noble gas, that will be inert. We are writing one example, then you can easily understand, like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So here you see, lithium will be alkali metal. Okay, its reactivity is high. So from lithium to beryllium to boron, its reactivity up to carbon. Okay, reactivity decreases. Then nitrogen is electronegative. Oxygen is more electronegative than nitrogen. Now fluorine is more electronegative. So what is happening? So here from this carbon to fluorine, their reactivity increases. So here decreases up to carbon, and here increases. And finally, when we are writing this one neon, this is the inert gas. So reactivity almost zero. Okay. So you can understand what I am telling. That is the properties of elements in a period. Next, if we discuss in a group, okay, suppose if we consider the alkali metals like lithium, sodium, potassium, rubidium, cesium, francium, what is happening? Metallic character increases, definitely their reactivity also increases, because the size increases and the last electron will feel less attraction towards the nucleus. Okay, that is why their reactivity is continuously increasing. Understand what I am telling? But if you consider in case of halogen atom like fluorine, chlorine, bromine, iodine, okay, as their electronegativity decreases, definitely their reactivity also decreases. Okay, so these are the variation of the properties of elements, okay, in a group as well as in a period. Hope you can understand. Okay, and other things are there, other periodic properties are there, that is ionization potential, electron affinity, electronegativity. Okay, that we are not discussing, and these things again you have to read in class 10. Okay, in class 10 syllabus you will start from the periodic properties. Hope you can understand what I am telling. Okay, and next in your syllabus there is some study of some group. So before going that, we have to discuss the merits and demerits of this modern periodic table. First we will discuss the merits. merits of modern or long form of periodic table, modern periodic table. Okay, first we'll discuss that when we arrange these elements, okay, according to their atomic number, then there is no problem of placing the isotopes of an element. We can place the isotopes in the same position because isotopes have the same atomic number but their mass number is different. But when we are arranging the elements according to mass number, definitely we should give the separate position for isotopes. Okay, so this is one of merit of this modern periodic table. Next we can discuss that from periodic table we can easily tell that how many valence electrons are there. Okay, suppose in group 1 all have the same number of valency, that is 1. In group 2 there will be 2 valence electrons. Okay, so from here we are getting some idea about the electronic configuration. Actually the position of an element, okay, in this periodic table is related to their electronic configuration. Okay, and based on this configuration, if the electron enters into the s orbital, then it is called s block, and when it is entering into the p orbital, then it is called p block. Then when the electron is entering into the d orbital, then it is called d block, and when the electron enters into the f orbital, f block. So whole periodic table is classified into 4 blocks, S, P, D, F. And when we will study about the orbitals, okay, the orbital is a 3-dimensional space where probability of finding of electron is maximum. Okay, so when you get the concept of orbital, then you can easily understand. But now you just try to remember that group 1, group 2, okay, that is the S block element, already we have told. Okay, and from group 13 to 0 group, okay, that is the P block, and in between this S and P there is transition metals. Okay, transition elements are there. Okay, they are called D block element. Okay, and just below lanthanide actinides are there. Okay, we are telling as A block elements. Hope you can understand. So this is another merits of this periodic table. Next, modern periodic table says that electronic configuration of valence shells are repeated at regular intervals. Okay, so hence the properties of elements are also repeated at regular intervals. Next, properties of elements can be predicted even before their actual discovery. Many elements are there, and finally we have discovered that Organus and Tennessine. Okay, and whole periodic table is complete, 118. Okay, till scientists are trying to discover, I think already they have discovered, I think 119. Okay, if you search in internet you will get. Okay, and so whether this periodic table is complete or incomplete, okay, the next research will say. Okay, new elements are coming or not. Actually in periodic table 92 or 94 elements are the naturally occurring and others are artificially prepared. Okay, that also keep in mind. And Mendeleev also left some places in his periodic table. Okay, that is the Eka aluminium and Eka silicon. Later these are discovered as gallium and germanium. Okay, so this is another merit of this modern periodic table also. And next we will tell about the misfit of the some atomic misfit of the atomic mass. Okay, of some elements in the Mendeleev period. That is also solved. This problem is also solved. Actually argon and potassium, I am telling about argon and potassium. So argon mass was 40 and potassium mass 39. But in the periodic table, okay, argon is first, then potassium. So whenever we are arranging according to the atomic mass, so it is not matching. Okay, and this is called misfit. Okay, but when we are arranging these elements according to the atomic number, you know that argon atomic number is 18 and potassium is 19. So in the modern periodic table, argon is coming first. Okay, then there is no problem. Okay, there is satisfactory explanation that why is argon is coming first, then potassium is coming. Next, modern periodic table is easier to remember, understand and reproduce. And the normal elements, that is and the transition elements and the noble gas have been separated very clearly. Okay, in this modern periodic table. Next we will discuss the defects or drawbacks. Very little bit of defect is there in new modern periodic table. First we can say that position of hydrogen. That hydrogen is placed with metals, but actually hydrogen is non-metal. So it has the properties, okay, matching with these group 1 elements as well as group 17 elements, okay. So that is why hydrogen position is not satisfactory, okay, whatever is given in the periodic table. But according to the atomic number, we say okay, but what is the position of hydrogen? You see, with metals it is placed. Next we can tell that according to the electronic configuration, helium should be placed in group 2A. Okay, after beryllium, just above beryllium, helium should be placed according to atomic, what I am telling, according to the atomic number, okay. But helium is placed in the 0 group, that means group 18. Okay, although it has 2 valence electron, okay, valence electron is 2. Okay, as its valence is 0, so it is placed in the 0 group or group 18. Okay, so this is also one defect. Okay, and last we can tell about the lanthanides and actinides. Okay, actually lanthanides, actinides are with lanthanum there is 14 elements, cerium to lutetium, and with actinium there is 14 elements. Okay, thorium to lawrencium. They are placed in the same groups. Okay, although their atomic number is different. So position of these lanthanides and actinides are also not satisfied, okay, according to their atomic number. Okay, so these are the defects. Next we will go to the study of group 1 elements. Very little discussion is here in your syllabus, okay. Actually all groups, that means S block, P block, okay, you have to study in class 11, okay, if you take science, 11 science, and others D block and A block also you have to study. Some P block is also there in class 12, okay. And now here we will discuss very little, okay. In actually group 1 elements are called alkali metals, except hydrogen, okay, hydrogen is non-metal, and others like lithium, sodium, potassium, rubidium, cesium, francium, okay, they have 1 electron in their valence shell, okay, that is why they are placed in the same group, okay, and their valency will be also 1, and they are called alkali metals because they react with water and producing strong alkali, and alkali, all of you know, alkali is a water soluble base, okay. Next we will discuss their characteristics, okay. First we will discuss about their electronic configuration, okay. So in the outermost shell they have only 1 electron and their general electronic configuration is NS1. Okay, first we can tell about lithium. Lithium electronic configuration we are writing that according to the orbital concept, okay. Later you will be able to understand. It will be the helium electronic configuration, then 2s1. Hope you can understand. Is s orbital containing 1 electron, and whatever you know, that means what I am telling, that KL system. So in K cell there will be 2 electron and L cell there will be 1 electron in case of lithium. Okay. After lithium which is there, then sodium is there. Sodium will be the neon 3s1. Hope you can understand what I am telling. And in this case, if you write according to the KLM cell electronic configuration, K cell containing 2, L cell containing 8 and M cell containing 1. Then potassium, what you are observing? In the outermost cell containing only 1 electron, okay. Potassium will be argon 4s1, okay. So here at K cell there will be 2 electrons, L cell 8 electrons, M cell 8 electrons, then KL, M, N cell 1 electron. Okay. So this is the potassium. Okay. This is the potassium. Okay. Potassium will be the 2881. Okay. 2881. Hope you can understand what I am telling. Okay, now here you see, in the same way whenever you will write the after potassium there is rubidium, so it will come krypton 5s1. So in this way you have to write the electronic configuration. Okay, actually in your syllabus up to calcium you have to remember. Okay, in your book all are given. Okay, that is why I am not discussing here. Next we will discuss all the elements, okay, are highly reactive and they do not occur in the free state. They are generally soft and you can cut with a knife, and if you keep these metals on open atmosphere it will catch fire. Actually what is happening, moisture will react and there will be formation of hydrogen gas and highly exothermic reaction, huge amount of heat will be generated, and that is why that hydrogen gas will catch fire. Hope you can understand what I am telling. And their boiling point and melting point will be low, okay, compared to the other metals. Hope you can understand. And these elements, okay, these alkali metals, okay, their salts are generally ionic in nature. Generally whenever they are combining, like sodium is combining with chlorine, sodium will transfer on electron from its valence to chlorine, okay, so that sodium can get the neon structure and chlorine will accept one electron to get the nearest argon gas structure, okay, and finally you will get NaCl and Na plus Cl minus, okay, will be formed. So this is ionic compound. Hope you can understand. Already we have discussed in the chemical bonding chapter, okay, that means atomic structure and chemical bonding. And these type of compounds readily react, okay, with oxygen as well as water, vapor or waters, okay, in the open atmosphere. So far we can show one reaction that sodium is reacting with oxygen and forming sodium oxide, Na2. So here you have to put 4 Na and reacting with this one, then you have to put twice Na2, okay. And this sodium oxide will react with what is a basic in nature and that will form sodium hydroxide. Sorry, NaOH, twice NaOH. Sodium hydroxide, okay. So in this way, okay, they will form what? Alkali. That is why they are called alkali metals. Now sodium can directly react with water. When sodium is directly reacting with water, it will also produce sodium hydroxide and there will be formation of hydrogen gas. Here if you put 2 here and here also if you put 2 here, then twice NaOH plus H2. Hope you can understand. And these alkali metals, they will react violently with water and they also violently react with what we can tell that acid also. So generally we are reacting metals with acid. Those who are placed above hydrogen in the metal activity series, they will produce hydrogen gas, okay. But here what will happen, generally these alkali metals we are not using for preparation of hydrogen gas because they react violently. The type of the reaction is exothermic. Definitely hydrogen gas will produce and it can catch fire, okay, and there may be this sodium or whatever alkali metal is there that can also may burst, okay. So to avoid explosion, okay, or any accident, okay, this is not generally done. If you want to see or experience this thing in your YouTube channel, okay, in YouTube, okay, not your channel, okay, in YouTube if you search that how sodium reacts with water, okay, you will get the videos. There also you can watch. And these elements, that means alkali metal elements, they have one valence electron. So that is why they will lose one electron and they forming the monopositive or positive ions, okay. And as they are releasing electron, definitely there is some elements will be there that they will accept, okay. So that means these elements, okay, that means alkali metal elements, okay, they are very good reducing agent. And finally we will discuss about the flame tests, okay. Already in practical writing I have given. So you have to take one platinum wire and you have to take that metal chloride salt, that is volatile, okay. And if you take it and if you just touch the platinum with the salt and just placed on the Bunsen burner flame, okay. Even spirit lamp also you can observe, okay, that lithium is giving some color, this is crimson red, and sodium is also giving golden yellow flame, and potassium is giving some lilac color. So from this color, okay, that means flame test, we can easily identify that whether sodium is there or potassium is there or lithium is there. Hope you can understand. And these alkali metals, if you want to obtain, okay, if you take molten sodium chloride and if you pass electricity, by electrolysis you can get that sodium. Hope you can understand. So in this way we have completed the discussion of the study of group 1 elements, and in my next class, and that will be the last, okay, of this chapter, last class of this chapter, okay, and I will discuss about the group 2 elements, that they are called alkaline earth metals, okay, and next group 17 elements, they are called halogens, and finally we will discuss the noble gases, that is zero group elements. So today up to this, okay, thank you.